Home for a Penguin is a physical science unit incorporating ideas about the properties of matter and how scientists and engineers can work together to solve problems. Let's look into the unit at a glance. This unit covers several second-grade physical science standards about the properties of matter. Each of the next-generation science standards correspond to a Missouri learning standard listed in parentheses on this chart. There is one standard that is a Missouri learning standard only. Take a moment to pause the video and review them. In this unit, students design a habitat that would allow penguins to live successfully in warmer climates. The anchoring phenomenon used to connect students to the science content is an image of two kids at the St. Louis Zoo during the summer. It shows that summers in St. Louis are often hot. This image will prompt students to question how penguins, animals who live in cold environments, could successfully live at the St. Louis Zoo. Students will continue to discuss this phenomenon throughout the unit as they learn about the properties of materials and how heat can change matter. Students will use the knowledge they obtain about the properties of matter to explain how penguins can successfully live in the St. Louis Zoo because of habitats designed by scientists and engineers. The design challenge for this unit is a culminating activity in lessons 6 and 7. Students are tasked with designing a habitat for a penguin. They used the scientific process to learn about how properties of materials make them best suited for a task. Students also spend time learning about how materials can change phases when heat is added or taken away. They then use the engineering design cycle to design and redesign a prototype and see if they can build a habitat that would be a good home for a penguin. Now that we have an idea about what students will study in this unit, take a look at the unit flowchart. This unit is divided into 3 sections, and there are 8 lessons total. In Section 1, students discover what scientists and engineers do and how scientists and engineers can help build a habitat for a penguin. This section will take about 5 instructional days. Here is the content level big idea for Section 1 and how students will figure it out. Students are first introduced to the design challenge where they will start to learn about penguins and their needs. Students then explore how scientists and engineers are different by discussing the scientific process, the engineering design cycle, watching videos, and listening to readings. Students figure out that scientists seek to answer questions about the world around them, and engineers design solutions for needs or problems. Students will continue to apply this knowledge as they consider what it takes to build an appropriate habitat for a penguin. In Section 2, students learn about the properties of matter. They will answer questions about what makes different materials unique and how matter can change. This section will take 10 days. In Section 2, students use readings, discussions, and investigations to observe and test the properties of matter, like shape, color, and texture. Throughout this section, students will use the observable properties of matter to determine how a material can be used or how effective it will be for a particular purpose. They will use this information to determine what materials are best suited to serve different purposes in a penguin habitat. Next, students discuss how heating or cooling materials can change their properties. They will see that some changes are reversible, like wax heating to a liquid and cooling to a solid. And some changes are not reversible, like the wick of a candle turning black when it is burned. Students will observe and discuss changes that occur to matter because of heat in a series of investigations. They will use this knowledge to consider how heat can affect materials within a penguin habitat. Section 3 asks students to think like both scientists and engineers when developing and testing a prototype for a penguin habitat. This section will take about 10 days. In Section 3, students use the knowledge they gained about the properties of matter and apply it to solving the problem of creating a penguin habitat. Students will go through the engineering design cycle to construct a penguin habitat that keeps penguins cool throughout a hot summer. At the end of Section 3, students will consider how the parts they used to build the habitat can be broken down to solve other problems. Students will have a class discussion about how different materials can be repurposed for different tasks, and then challenged to develop a new purpose for the materials they used in their penguin habitat. By the end of this unit, students will have learned how scientists and engineers can use the properties of materials to solve a problem. For more information, visit our website, myscipartners.com. mySci, inspiring the next generation of scientists.